Right. So actually, this talk is more focused on the NCP Iceland, which stands for the Copernicus Atmosphere Monitoring Service National Collaboration Program for Iceland, which is basically a project led by three institutions, by the Agriculture University of Iceland, Icelandic Environment and Energy Activity, and the Natural Science Institute of Iceland. And the project has already started. So it is from July 2025 until June 2028. And you can see the responsibility person for Iceland. So it's me, Nisha Hrabalíková, and Linur Artnason, who was having the presentation in the early session today. And then very important and key parts of the project is also the University of Belgrade and especially the Republic Hydrometeorological Service of Serbia, from where also Ničko is. So that's Slobodan Niskovic, Bojan Cvetkovic, and Anna Vukovic helping us with especially the modeling part. And there are several VPs in this program, and we are basically here in Iceland focusing mainly the VP2 and VP5, which is the direct use of CAMS products, and also VP5, which is the support of in situ measurements or creating new networks. So that's the general introduction of the project, and it's a phase 2, which I already mentioned. So you saw the details about the phase 1 already last year, because it lasted for 18 months, and in that phase we mainly only focus on the dust sources. But the main activities in the phase 2 is basically the direct use of CAMS forecast, which should be targeted for the public info and official alerts to be provided at loftguided.is, which is the national, basically, air quality website to provide information to the public. Then integration of the particulate matter 10 and 2.5 together with gases with real-time data. And that involves also the model output statistics and exploratory. And then validation against the national network and dream operational model for Iceland, dust operational model for Iceland. So the main outcomes, what we expect, is the public bilingual national air quality hub at loftguided.is, which is the air quality. And there will be the integration of the CAMS layers, which are focusing the CAMS forecast in with the data from the in-situ station provided in real time. And for example, other layers like images from road cameras or any available information for air quality in Iceland. Then based on this hub, there will be also official alerts provided and guidance. And the other outcome is the validated performance of CAMS products under Arctic conditions, which are quite challenging. So we actually also, thanks to this project, capture a lot of extreme events. And as the title said, we are the one who are responsible for this NCP for the Iceland, but the dedication is to basically raise awareness on air pollution in Iceland, which is critically low here. And so people are not much aware. I dare to say that because I come originally from very polluted, air polluted country. And then the dedication is on both to public and stakeholders, but we need their kind of participation to create the hub into something that will serve perfectly everybody. So your feedback or what you suggest, it's really important for us how to lead this NCP. So for the working package 2, which is the direct use of CAMS products, so we in the map in the air quality hub, we will use two forecasts. One is the European based and one is the global based forecast, and that's due to the location of Iceland is in rather west corner of the European domain. So for the long-range transport even, but also the long-range transport of local air pollution, it's quite crucial to use the global forecast. And then in the bottom, you can see the GAMS products which will be integrated. So it's both particulates and gases. And on the picture, you can see the system architecture for this air quality Iceland wet map. And if you have questions about that, it's the best to contact Michaela Hrabalíková, who is responsible for that, for the VP2. So this is the example of the final outcome, how the air quality map will look like. So at the moment, you can check what is available on this link, and it's being improved, and we have this 3 years for that to do that better. So this is also kind of appeal if you have any additional in situ measurements, although maybe from low-cost instruments, it can be integrated and the information added. So there are many places in Iceland that are not monitored, and any basically observation would help. And you can see it also includes the background data. You can turn on layer for the soil surfaces, for example, high erosion areas and dust hotspot and different other layers. And this can be also later actually edited. So the more info, the better. For example, for biogenic sources, there are so many different ideas. Of course, ocean is also a very important source for air pollutants, both particulate and gases. And for the VP5, which is my favorite, is the support of in situ network. So there are two independent in situ station network. One is the regulatory network of the Icelandic Environment and Energy Agency, which involves a lot of stations. It's fantastic, located mainly around the urban areas. And the second one is the network run by the Agriculture University of Iceland, which is specialized on dust. And these stations are marked here in the green crosses. So these are located very close to the active dust hotspots, but not exactly on them, because we have experience in the phase one that locating instruments directly in the dust hotspot means that it will not last very long. So based on that, we will be providing comprehensive data for GAMS validation, national air quality assessment, and also dust assessment, which might serve for further climate assessment, for example, like AMAP report, or hopefully even for IPCC report. So the main outcome is this unified air quality national hub. And again, we do what we know, but if you give us idea what else should be integrated, the capabilities are there, and from the technical point of sight, it is doable. So this is finally some pictures from the field. So this is the station in the south on the right in Mirar. That's about 10 kilometers south of the main dust hotspot called Myrdalsandur. But as soon as we installed it there, we found out we have also long-range transported dust from areas of south of Vatnajökull. And this is nice that in the data we can distinguish between the local sources and distant sources because of the proportion of PM 2.5 and PM 10. Sometimes the proportion are very, very high. So that means a lot of PM part, there is a high part of PM 2.5 and PM 10, and that's sometimes similar what we see in Reykjavik because the dust comes from longer distances, so it's more fine. And the west is the station in Möðrudalur in the northeast Iceland. And then also part of the project, we go directly to Dingjusandur deserts in August always, because it's accessible only about 3 months per year, and we measure the in situ concentration over there. And here are already examples of some extreme events we captured in 2025, so severe dust storm in September 2025 in south, where the concentration were over 1,000, and then during the volcanic eruption in the Reykjanes Peninsula, which really provided this peak of enormously high concentration for SO2 measured by the Environmental and Energy Agency. And as I mentioned, Anichka already gave a talk about it. A very important part of the NCP is integrating dream model and basically provide the recommendation to CAMS how to make the local sources more visible and provide forecasts for people. When it comes to dust, of course, gases, it's a different part. And then the VP6, which is obligatory, so it's on communication and user outreach. So we use the website of IceDust. Feel free to visit it. There are also some info on the copernicus.is. Then the platform, the map, the interactive map, it's on this link. And then quite often, and the most kind of basic place is Facebook group Dust Storms in Iceland, where we actually, after launching the CAMS phase 1, we actually exceeded 600 users. And that's for Icelandic environment, actually a really, really good number. So, and it's still increasing. So people are also posting dust storms when they see it. Soon there will be post about the storm yesterday. And in this VP6, so you see what we have to do, what is the activity and how to involve the stakeholders and users. So here I would be again appealing for all the institutions, but also individual people to just to approach to us or have a look on the map and provide us with feedback. There is always feedback tab where you can provide us with information what should be included, what should be done, and or that you maybe don't even know what kind of air pollution exists and you are interested. So any good idea. And okay, I should finish. So yeah, and of course I'm always presenting these at the different conferences and congresses. So again, it's very important to get the info from you how to head this towards absolutely perfect air quality hub for Iceland. And then this is a really nice picture of how it's actually evolving. So we will create, or we are already having this air quality national hub, which is still under reconstruction and will be. Then it attracts the media and social updates. Then it's the community campaign, stakeholder outreach. We also provide these workshops, for example. Then we have presentations at this policy forum like Arctic Circle or Arctic Congress to be this year. And then it's the professional and academic outreach through the conferences. And then everything should anyhow be put together and we need to get the feedback. So that's very important. And the added value, at least from my point of view as a scientist, is that we managed to capture these extreme events. So that's the plus. I mean, we can finally prove that maybe air quality outside Reykjavik can be very bad in the area close to the dust hotspot, which we didn't know before. But we also, due to this long-term measurements, managed to measure the extreme events. And one of them was in summer 24 in Northeast Iceland in Usandur. And instead of dust, we actually measured black carbon because it was a massive plume from the mosses burning around the active eruption. So it wasn't the eruption itself, it was the mosses. And you can see in the typology and size of the particle here that mainly that was the material, and the PM10 went up to 25 micrograms, which is a lot for black carbon. Then we also measured two incredibly rare events for the long-range transport of Saharan dust to Iceland. And that's where you can see the different CAMS products are actually doing very, very good forecast. It was a very extreme event for late November in Iceland. There was a temperature of 26 degrees. You don't see that even in summer here. And our station is located northeast, so we did not really see it so much in west. Here in Reykjavik, but because we have the station in northeast, you can see we measured concentration for Saharan dust reaching almost up to 200 micrograms. And we can also recognize it by eye because it's a very reddish material compared to the different color of the Icelandic dust. And third was actually, so this first peak was the Saharan dust arriving to Iceland. And straight after that, it triggered really strong winds. And we had incredible Icelandic dust storm reaching almost on the visible part of of a satellite all the way to Scandinavia. And that was during actually North Dust project between the Nordic countries. So right after that, we have our own event. And for example, in Eilstadir, it caused the swimming pools were filled with a lot of sand. So it was very bad storm. And that's also the image from that storm, sticky material on the glasses. So thank you for the attention. And once again, the main message of this talk was that we are creating this air quality hub, and that should be according to the need of people, what we shall include. So we are very keen on getting feedback. I hope I said it clearly. Thank you very much.
Information related comes Copernicus. I'm sure that this will motivate the other groups to join or to collaborate. So I would like to ask people, the audience, if there is any question here.
I couldn't believe that you have measured the black carbon, but you explained us.
Yeah. The black carbon, yes. It was a big surprise because it was really snowing that summer, so there was no gas. It was covered in snow, and then all of a sudden, how come it's so hazy here? And it was, I think that room had to travel around 300-400 kilometers from Reykjanes Peninsula to North. So many different extreme events are possible.
Any other question to Pablo?
Okay, so
yes.
Norm, please ask. Thank you. So can we ask Norm? Can you please raise the question?
Yes, the smoke was, I guess, Canadian smoke, and it was high altitude. And would this be an example of smoke settling down to the surface?
Yeah. We detect these Canadian smoke very often here too, which is a great idea for the hub as well. But this wasn't. This was indeed the local mosses from the eruption. There was an ongoing eruption in southwest Iceland, Reykjanes Peninsula, and the source was from there. And it was detected. I met my colleagues at EGU, and they confirmed they detected also in Svalbard, and it wasn't the Canadian smoke at the time. It was in late August 24.
Okay, thank you.
And Santiago?
Yes, hi, good morning. Very interesting. Right now, I'm also doing some sort of outreach activities where I have to talk to local air quality managers and ask about their needs. So what you showed is really good example because it's good for getting ideas and what we can do on this side. So I was wondering, you didn't show much about incorporating remote sensing information in your interface in the portal. I didn't see the option. So I understand remote sensing can be difficult because well, you are in a very cloudy area, and creating a portal and bringing the information can be difficult for little amount of information. But in any case, in your opinion, is it useful to bring remote sensing information to the public and through your information system? And the typical satellite picture, like you showed examples, you can go to Worldview and get something. But alternatively, I wonder if there are other sources of remote sensing that can be useful for what you do, like surface some photometer.
Definitely from Sentinel, for example, Sentinel 2 and 3. It's in the true color, at least the most usable for Iceland. And remote sensing provide the evidence. So without remote sensing, we wouldn't even, maybe like yesterday evening, if you don't look at the satellite, you are not entirely sure where are the particles coming from. So since decades, remote sensing is always number one tool we use for making sure if it's dust, because we didn't have the measurements in the field neither. So
right. So one thing that is very practical is that you maybe there is a good satellite overpass, but it's access to the image. Sometimes, you need a good portal that will create the image for you and make it available. Do you have such system? Do you have one of your own, or you use one of the public portals to
Use the
access?
public ones, but I'm aware at the University of Iceland they use the integrated through GIS, and that's
Okay.
also nice that they provide this picture in the Facebook group Customs in Iceland. So
Okay. Okay.
that's
Good.
one of the
Good.
basic evidence. Yeah.
Yeah. Okay. Good. Just one last thing regarding remote sensing. One of the critical parts is speed you get the image. Sometimes you have, the satellite goes over Iceland, but you don't get the picture until 3 hours later, which doesn't help very much. So that's the other, I guess, inconvenience for doing real time monitoring. And so it sounds like the in Iceland, you guys have access to real-time data? Like, it's relatively fast to get those Sentinel images?
I don't know how long it takes. Alex, do you know? I'm not exactly aware. Hopefully, maybe somebody in the audience
Okay.
here now is the timing. But I mean, looking backwards 10 years and today, you get the info, I would say, much faster. And
Yeah,
also
yeah.
the public kind of servers, even for the EUMET view lately.
Yeah.
So
So I guess the point is
simplify.
that when you look at remote sensing data, it's not only that the satellite goes over at the right time, but also is how from the time the picture is taken from the satellite to reach the user, you need to have like a really fast time, and that doesn't depend on that depends on other people who are not here. So it's a
It is,
practical
and
aspect. Yeah.
I think they release it, you can find it within several hours after already. At
Right.
least Terra.
But the question that you open, Santiago, probably is something that could be a matter of discussion with the CAMS people, with the ECMWF.
Mhm.
So Sentinel are there, but the question is how fast the user can see it at the island, in Iceland,
Mhm.
right?
Yeah, so they're very practical things. For example, until a year ago, there was a web page, a private web page, Sentinel Hub, I remember, and you could get the web page, the image within half hour or within a 1 hour. You can go to the web page and get it. But then that web page, accessing the imagery became you have to pay. They just put it behind a wall, and then they delegated the same function to Copernicus. So now there is a Copernicus website to get Sentinel
Yeah.
images, but they take longer. They take longer. The images don't get as fast as the private one. So those are the practical things that you encounter. Yeah.
Because of the kind of sparse passage over Iceland, we are usually fine with 1-2 pictures per day. So, good, thank you.
Okay, thank you. Any other question before we switch to another presentation? If not, thank you very much.
Thank you.
So the next presentation is by Aldona Vasiek,
There.
Canada.
Thank you. Presentation, sorry. I just do the setup right already, and we are report. Just let me make sure we are sharing on. Yeah, no, sorry. Right there. And this could. It hit Warren. Oh, it hit itself. Yeah, that's the thing. Don't move the mouse away from them like that. Oh, thank you.
So Aldona, you have
Thank you. Okay, so speaking of remote sensing, it's great to be here. And this next talk is about satellite-based evidence of dust emission over northern Canada. So it's an update over what I presented last year. And one of the updates as well is that this work was initiated by Ian Ashpole, who has since moved on, and we have Brian that joined our group and also was integral to bringing you the work that I'm going to show today. So this is based on a paper that is now in final publication in ACP. I wanted to be able to say go look at it, but it's not there yet. So within days it should be there. Okay. I don't have to spend time on this, except to say perhaps that in situ research on high latitude mineral dust aerosols is exceedingly hard, right? Which is what motivates us to go to remote sensing approaches, which of course are imperfect. So only a handful of source areas have been documented in Canada's north. That is documented with eyeballs on the ground. There are likely many more. We know that from work dating back to Ina Tegan's work and before that. Like also there's probably many more sources like what Alex was showing yesterday in this talk. So our method was to look for and tabulate extreme dust loadings in high res over 20 years over land, which is near dust source areas. It's a logic of where there's smoke, there's fire, or where there are recurring extreme dust events over 20 years, there's potentially a dust source there. The details of this method I will review. So we're using L2 Modus deep blue aerosol products at 10 kilometers. And we're calculating an optical depth of dust. And there's two ways, and we're using, what I'm going to show in this talk is all the Pu and Ginu approach, where the dust optical depth, PG 2016, it relates to the aerosol optical depth modified by an empirical function involving the angstrom exponent, which of course tells us if there are large particles around. Oh, wrong way. So both of these formulations look for coarse dust modes, and that's important because those are the ones that are going to stay really close to source regions. And we're using all the QA levels in this data because otherwise you lose 5 times of the data. And it's been studied and recommended also by others that this is helpful and not the worst thing to do when your goal is to locate dust sources rather than to have a final quantitative dust optical depth product to compare with a model, which would be a quantitative comparison. So we're looking for the FOO, the frequency of occurrence of extreme dust events, where extreme means the dust optical depth went above 0.5. And this is, again, spanning 20 years of data. And we regrid this to 0.1 by 0.1 degrees. So here's how this might look for a scene. So this is Modus aerosol optical depth in world view. This is the western part of Baffin Island in Canada, quite distorted. And you're looking at AODs here of around 0.03. So kind of widespread AOD of 0.03, which might be cirrus clouds. Didn't get into so much detail there. But these optical depths here are over 1. So they're between 1.1 and 1.5 in this blue box. And this blue box, when you zoom in, it more or less, with the distortion, it's a little hard to tell, but it more or less corresponds to this glacier here. And that location marker is us. We're going to zoom in a little bit more. So that location marker here now shows us this is 1 kilometer scale in the top right. So it shows us we're at the edge of a glacier and we have the outwash plain here. And this is even this spot here with 20 meters, but the 20 meters is a smaller bar than the actual 20 meters written here. So this tiny little thing is the 20-meter scale. So some of these have excellent imagery available that you can go and look at. So it looks like So in our analysis, that was the previous slide was showing aerosol optical depth. The dust optical depth would be a little bit smaller, but in our analysis, only this data here would be retained as the extreme dust emission event. And it looks like it makes sense because it's in a glacial outwash. Okay, so over 20 years, the number of observations, it decreases, of course, going north with the sunlight. And so the frequency of occurrence of this dust optical depth, according to PG 2016, of greater than 0.5, it looks like this. So you have areas lighting up in the Arctic archipelago, and there are also some areas here that light up. We discussed this at length in the paper, but they disappear in a relative plot as a percent of observations. They're more related to agricultural emissions. So this looks like dust is just about everywhere, but that's not entirely true. And that in some places, up to 50% of the time, there is dust that's being detected. So when there are measurements, there's few observations, but when there are measurements, it is dusty in some places. Again, so this is 20 years, that's important. A couple different things. You might wonder what the effect is of different cutoffs. So in this panel, if we ask for extreme events, so greater than 1, we lose a lot of places that meet that criterion, but some are retained still. And in the rightmost panel for you here is the effect of staying at 0.5, but asking for the best estimate data, so that highest quality data. And it has a similar effect that only the strongest dust sources remain here and there. Okay, so that's thresholds and quality flags. And here's a detailed look at the threshold rising from 0.1 to 0.2, 3, 4, 5, 75, 1.0, and 1.5. So, so this is the details of the DoD thresholds on the right. And on this side here, we have a distribution of the dust optical depth greater than, well, that percent shouldn't be there. It's just greater than 0.5. And it's in this rectangular box, which we're calling the Arctic dust belt. So most of the time, the frequency of occurrence of dust being more than 0.5 dust optical depth is 0. So most places are not emitters of extreme dust, but we have only a few points there that have a decreasing number of points that have a frequency of occurrence that is more like 10, 20, 30, or 40 events over 20 years. And so, I mean, the mean over this entire geographic region is 9% of the time, the median is 4, and the mode is 0. So most of the time, extreme events don't happen, so that's how it should be. Trying up here, it must be the dust.
Yeah.
Or jet travel.
No, it's the dust.
Okay, so the seasonal dependence of this is that the majority of extreme dust events occur in June, July, August, as they should. So here, the top panel is showing you the frequency of occurrence in absolute terms, the number. Here's the frequency occurrence in the middle row as a relative percentage of observations. And here again is the number of observations increasing towards summer with that sun-synchronous sampling of MODIS and disappearing entirely in October and April, with May and September being the shoulder seasons. Okay, so we did some work to compare our locations to the SDS SPM source intensity map that we've been hearing a lot about. So here's the source intensity map for July, showing the areas that have a high potential to emit dust with the right wind conditions. And over here, this is a map of logicals. This is different colors represent two things coming together. So it's the union of the frequency of occurrence being more than 10%, and the source intensity map having reaching a threshold of 0.5, so like half of the maximum. And so that happens in fewer places than you might think, or it's not widespread agreement that we have this condition being met of dustiness and also the satellite-based dustiness matching the source intensity map potential of dustiness. And then we have the two colors, which are, so that's agreement in red. In white is also agreement, but it's just, there should be, the satellites don't see anything and the source intensity map does not predict that that's an emissive spot. So the interesting parts are the greens and the blues. The greens are over-emitting according to observations. So the frequency of occurrence in the satellite data is more than 10%, where things are green, but the source intensity map was on the lower side of the potential to emit. And the blues is under-emitting. So we don't have a lot of frequency of occurrence, but the source map said this is a fairly active region. So this is also thresholded, and you can easily ask yourself what happens if you change these thresholds, and we did, and we played around with this. Using our 10% is reasonable from the standpoint of extreme events, shouldn't be more than 10% of all events. And the SI cutoff of 0.5 is a little bit arbitrary. We played around with this. Okay, so this, this area here from 75 west to 125 west and 70 to 80 north, we're sort of roughly calling that the Canadian Arctic dust belt, where you have agreement with the source intensity map and some over-emitting, more over-emitting in the observations as compared to the potential for emission. So some of these new dust sources, if you look at, just don't touch it. If you look at that map in a little bit more detail, so this green area here was over emission in observation. So we went there and looked at what it looks like. And I mean, it looks geologically consistent, like that could be a source area where the wind speeds are consistently on average high. It's an area of strong weathering and erosion, finer sand, silt, and clay. So this makes some sense. This one here at the border of Labrador and Quebec is also a very windy plateau, recently deglaciated in geological terms, leaving behind a lot of unconsolidated glacial sand, scarce vegetation, and soil formation. I actually have a geologist in the neighborhood in Halifax who's been there who said, yeah, dust all the time. So that was pretty fun. But if you now watch the switcheroo here. So in the map of not source intensity, but in one of our own maps of the frequency of occurrence, we had a region here that it just doesn't meet the 10% threshold. And it's really quite big. It's one of the most prominent features of where we have some activity happening, though not less than 10% of the time. So it doesn't meet the threshold. It's in northwest Nunavut. It's also a glacially scoured plateau that is windy and unvegetated. And it doesn't look like much here in this picture, but if you go to 10-meter Google Earth imagery, it looks to be really, really interesting. I spent more time than I care to admit flying in Google Earth, but it's not like a sandy plain like here, so it wouldn't be active all the time, but it certainly is just a rocky place that maybe has a lot of much lower grade emission than our cutoff of dust optical depth of 0.5. Okay, this one I think I'm going to go over really quickly because I showed this last year, which is just to say that if you build an observation station that's sort of upwind from a glacial valley, you're gonna get dust a lot of the time, and this is Kuani Lake in the Yukon. So it's here. But then the other station that I'm just gonna, so here's the three sources in the squares that I just discussed with you. And then the next one here is on Cornwallis Island, Resolute Bay. So if you build a station, did I say upwind here? I meant downwind. If you build a station downwind from the dust sources, you will catch dust. If you build a station here to the left of a dust source against, the prevailing winds that are wrong, you're never going to see dust. So that's sort of the problem with Arctic validation of dust events, is that you really need a targeted measurement place based on the prevailing meteorology. So that's in the paper in some more detail as well. This plot got really updated on the temporal change in the annual mean frequency of occurrence of extreme dust events in the Canadian Arctic dust belt. So the question is, this is the annual mean frequency of occurrence of AOD greater than 0.5, and then the two DOD formulations. And so the question is, do you see a temporal trend in the orange ones, where this one in the solid symbols is the one I've been showing all along this presentation? So, I mean, not really, sort of. If you divide this timeline into like the first 10 years, you might get this kind of an average. And if you divide it into the last 10 years, there's a lot of up and down. So maybe there's more dustiness, but it's not very clear. So we did look at 20 years of daily mean era 5 meteorological fields in a matching time period. And there was a significant and negative correlation between snow cover and aerosol optical depth only, but not between snow cover and dust optical depth. So the correlations here are negative, as you might expect. So the less snow cover, the more dust. But the p-values are not significant. So again, there's some squint your eyes type evidence that maybe it's more dusty, but it's not really statistically significant for dust optical depth. So these plots are showing you your annual means of these environmental variables that you would expect would all relate to dust emission. The last update is to the Calypso plot. So we looked at Calliope dust type in June, July, August for 2006 and 2020. So 14 years of Calliope data. So it's based on All Sky L3 data, which is itself based on L2 data at 5 kilometer resolution. And all we're looking for is a Boolean, like was there dust or not? And so this plot is showing you that L3 number of dust events, that number of dust type readings from Calypso, but we had to average it from 60 to 80 north because it's such a sparse data set. Again, 70 meter laser footprint. It's nothing like MODIS, where you have like 2,300 kilometer swaths, so you get lots of coverage. And this is the median surface elevation from 170 west to 0 Greenwich. So these red lines here for the longitude bands of the Canadian Arctic dust belt. So there is some activity here in dust detections by Calypso, but there's also activity over Greenland and like right over top of Greenland and east of Greenland. And so we did, rightly so, in the vigorous review process, the question was asked about whether that could be diamond dust that's just being mixed with dust by the satellites. And so here, these three boxes here are showing you the Canadian Arctic dust belt, a box that we were calling sort of Greenland in this kind of a plot, that's green. And then this box here on the far right, very narrow black rectangle, that's a box that spans this plume of Calypso dust type detections. And so he looked again at the corresponding June, July, August MERA. MERA 2 variables that have to do with telling apart whether this is dust or diamond dust. And so in these three different regions, so we have the Arctic in black, Greenland in, as defined in this box, so I understand it doesn't match Greenland exactly. Greenland in green, and the sort of Greenland, Iceland, East Greenland, Iceland is blue, so that corresponds to, oh, that's a blue box too, I couldn't even see the color. It matches, it's good for you. So anyways, the cloud ice is really quite low, and cloud ice optical thickness is also really quite low for the Arctic region. So for this spot here and for the East Greenland, Iceland region. And also we computed the relative humidity over ice. And so for all three of these regions, we are subsaturated with respect to ice in a climatological sense, which matches the climatological period of the Calypso data. So what we conclude from this is that it's not likely that it's diamond dust in the Canadian Arctic and the East Greenland sector. But over top of Greenland itself, the temperatures and temperatures are routinely below the freezing point here. And although it's subsaturated with respect to ice, we are sort of suspicious that Greenland diamond dust versus dust confusion can't quite be ruled out. So like this maybe is diamond dust, but we're going to do a little bit more work on it to tell them apart. And yeah, that's my wrap up here. So we detected these hotspots of frequency of occurrence of extreme dust events. They're in decent agreement with the sand and dust storm database for July, defining Canadian Arctic dust belt and giving us a regional scale and observation-based confirmation of dust emission hotspots in the climatological 20-year sense. Some are over-emitting and some are under-emitting as compared to the source intensity maps. There's 3 new source areas that would be worth looking at based on this analysis. And as I said, catching dust in ground data is sparse and idiosyncratic. It depends on your location. There's some evidence for increasing activity of dust sources in time. Oh, do not sign me out. 5 minutes for questions. And yeah, some evidence of homogenized dust signal in Calliope data. Okay, done.
Thanks, Aldona. Very interesting. Very important, by the way, for different scientists, including modelers, sources.
Thank you. I think it's, yeah, we got a fair bit of work to do still.
Okay, time for questions. Yes, please.
So yeah, amazing research. Thank you. Yeah, I should go to the box. Sorry.
Can you stop the reboot somehow?
Stop sharing or yeah, like this, so they can see. Yes, perfect. But my question would be, so out of the study, so it looks like the Ellesmere Island would be the most dusty place from the at least archipelago of Canada.
Ellesmere, Baffin Island, yeah, all around there. It looks like there are dust emission hotspots to be looked at. So, I mean, it's not like news, but like it's satellite.
I've been most aware of the Kluane Lake because a lot of research has been done there.
Mhm.
So, there are not really in situ measurements in any of the archipelago, is it?
No, there are very few stations.
Yeah. Thank you.
Okay, thank you. And any other question?
I think there's a fair bit of activity online, and so
So those who raised the hand, just
I think Ali raised his hand first, then Santiago and Miguel.
okay. So Ali, can you ask?
Hello. Do you hear me?
Hi.
Yes.
Thank you for your presentation. I just had a couple of questions, but I'm just asking my first question. As you know, optical depths, aerosol optical depths, kind of shows dust emissions and not dust sources. So when we have like AOD over a region, we should see some dust emission at least over 20 years when you have analyzed 20 years of MODIS imageries to get to these results. And from aerosol optical depths or dust optical depths. So I think we should see one or two examples of real dust plumes in RGB MODIS imageries, but I didn't see any RGB any dust emission in RGB imageries, and just I see some optical depths that presents dust source in your research, not dust emissions. I didn't see any dust emissions. And also I saw a graph in your seasonal dependence slide. You were comparing some AODs in different seasons. And you said, okay, from July to August, we have the most dust emissions. But from like October to April, we don't have that much MODIS imagery to compare with like July to August. So I don't know what was the reason behind that slide to compare when we don't have any MODIS imagery in like winter season, and you are comparing those results with the summer. Thank you so much.
Okay, so I'm really conscious of the fact that this computer is gonna reboot.
Yeah, just writing that to Chris.
I feel like we're gonna have to come back to this. So again, dust optical depth is being used as a proxy for the location of dust source areas. It is true that this is not a confirmed detection of an emission like using visible imagery as the kind of work that you've done. And as we both know, that work is excruciatingly hard to do because 80% of the time the Arctic is cloudy in the summer. And so it is really, really hard to see, which is what motivated our work to go after it in this indirect way. So that's one. Now about
Okay, bye.